Let's have a look at program design again, now that we have a few more complex things that we can work with, such as our structs and enums, as well as the functions and procedures and arrays that we've seen. As we know, software is changing the world. It's being embedded in more and more things. It's controlling more and more aspects of our lives. To really engage in this revolution, we need to be able to take advantage of these software or this computing power by developing software. Now, program design, when you're getting started with programming, can seem challenging. Really, where do you start? How do you start thinking about building your own custom programs? Well, with the right approach, you'll be able to tackle any programming challenge. It's just a matter of working out how to go about designing these solutions. How do we do this? We tackle the tasks iteratively with a focus on managing data and organizing functionality. So these are the two aspects of our programming. We have structs and enums for organizing our data, and we have functions and procedures for organizing our functionality. We've also got arrays for managing data as well. I shouldn't have forgot that one. We then iteratively build our solution by thinking about how am I going to structure the data, how am I going to structure the functionality, and then iterating, building small piece by piece by piece. When you're starting out, the first step is not usually to think about the functionality so much. Start by thinking about the data and design the custom data types that you're going to use to organize your program's information. How you organize the information will greatly impact upon the functionality that you use, because the functionality can only do things if it has the information that it needs to be able to make the decisions that you're going to need to make and to perform the outputs that you're going to need it to make or it to generate. So the data is really, really the important part of your solution. So start by thinking about what are the custom data types? What are the different entities that I'm going to have in this program? How do they relate to each other? Those sort of questions. Once you've got that sorted, and you should be able to hopefully visualize some of the ways in which you'll be able to use it as you do that. Part of this process is the idea of abstraction. So take the concept, the thing that you're trying to model, picture it, and then imagine what the important aspects are related to it. And try to make your program's code reflect the reality that you are modeling. That's what abstraction is. Taking some reality, abstracting away all of the bits you don't care about that reality to focus on the bits that you do care about. And we can do that in programming, or that is really what we're doing in programming a lot. So we can take a concept, we can break it down into the essence of that concept and only the bits we need to work with. We then structure that as a struct or an enum in our program. Once we have our data structures, so the different structs and enums, arrays, and how they're fitting together, we can start to organize functionality. So the idea of our functions and procedures, we can design numbers of these, the idea being each one should be small and designed to do one identifiable task. The name of the function or procedure should then tell me very clearly what that task is. Now, the task might combine together a number of other functions and procedures, so it might be a larger, more complex task, but inside itself it will be a small amount of code just calling other functions and procedures which are performing different actions. It's just like open window, for example. It's a small identifiable task, but if you look at the code behind the scenes, there is a lot of stuff going on in order to do that. So it's actually quite complex, all of the bits that it's doing. But if you look at the code for Open Window itself, it's actually reasonably small too. It's just calling other functions and procedures, and they're calling other functions and procedures, and they're calling other functions and procedures. And we're getting to have lots of small functions and procedures that all do one identifiable task, that work together to achieve the outputs that we want. So think about breaking up your program into these small functions and procedures. Think about the functions and procedures that you're going to want to start with, and then how they're going to work. Now, what you don't want to do is try to design your entire solution all in one go. Because if you do that, it'll take a very long time, and most likely it won't quite work the way you wanted to, because when you get down to actually coding it, that's when you'll realize, oh, hang on a minute, I don't have this information in this struct. What do I do? And if you've spent ages and ages designing everything, then it's going to take you ages and ages to fix your design again. So what's best is to do this iteratively. build a small piece of your solution. Get that small piece working. Once you've got that small piece working, go on to get the next small piece working. But in each case, you've got to be a little bit forward thinking. So probably spend a little bit more time thinking about the structs and enums that you want to underpin everything at the start, but then very quickly get a bit of the solution working, write a few functions and procedures, get them fitting together, the main core parts of your program, and go, yep, okay, it's all fitting together, run it, see that it runs, test that it works the way that you want it to work, and then go, okay, cool, I know that bit's working. Now let's add this new bit. Do I need to change the data? What do I change in the functionality? Implement both bits, test it. Okay, that bit works, and keep doing that again and again and again. You should feel very nervous the longer you are building something before you've tested it. If you're not testing it frequently, then you should be worried. I get worried. I've been doing this for a very long time. Even for small programs, you're going, oh gosh, I've written a lot of code. I know that I'm going to have made mistakes. If I compile and run this, it's going to take me much longer to fix those mistakes because I'll have forgotten all of the different bits that I've changed. So frequently compiling and running your program is absolutely critical. So will you be able to start designing your own software solutions? Software design is challenging, but with a few strategies to guide your efforts, you can be successful. It's a matter of putting those things into practice and trying and asking for help, and you'll be able to get there. Tackle the task iteratively. Focus on managing your data and organizing your functionality. That's the three different parts of it. Iteratively work, focus on managing data first, and then organizing functionality. Now, any software can be built this way. This is how we build really big software solutions, how we build small software solutions. Depending on the situation, you might spend more and more time in the design parts early on. Particularly if it's something for a safety critical, it's going to spend a lot of time in the design, a lot of time in the testing, probably less time in the implementation. But within every project, we are always doing all of those bits together and trying to iteratively build towards our software solution. I hope this has been useful. We'll have another video where we'll put these into practice. But really, at this point, it's about putting it into practice yourself. Look forward to seeing what you can come up with, and happy to help. Just ask questions on the discussion board, or raise a topic that you'd like to talk about. We'll do what we can to help you get started with this.